Hello and welcome. We are the team of Craft Square, and we are excited to have you here explore the project with us. So, Tangible Compass was initiated by our team during the summer of 2024 in collaboration with other organizations on holding the Fab City Challenge China in Shenzhen. So, initially, it was the name of a single artifact, which represents the core concept of this project. That is a compass you can feel by haptic sensations. However, as we continued the development and the progress, Tangible Compass gradually became the name of the entire series. So along the journey, we started from accessibility design, leveraged mechatronics and haptics technologies, engaged in academic activities, and further expanded our influence through education and entrepreneurship. It really has been a long journey until here, while it is also amazing to achieve what we have just in half year, 6 months. So now let's bring back the time to the summer of 2024, where we incubated this project, and our team will take you through this journey in detail.
The goal of this project is to develop a technology that better assists blind and low vision community to navigate around the world and also empower them to travel independently. Our team visited the Accessibility Research Association in Shenzhen and talked to visually impaired individuals to understand the pain points and needs of the BLV community. Also, through conversations with the organization, we learned about an existing collaboration between the Accessibility Research Association and the map software company that aim to enhance navigation tools. This insight led us to ask, what if we could extend this idea into a physical wearable device?
Specifically, we found the audio cue for orienting navigation is intuitive enough when protecting to body behavior in an urban walking environment. We proposed using haptic force feedback to transmit such information, so our team set out to build the Tangible Compass, a wearable navigation aid designed to help visually impaired individuals navigate their environment more intuitively. Our demonstration of Tangible Compass Prototype 1 is in the video below. Feel free to learn more about it. After 5 days of the Fab City Challenge, we successfully developed the first prototype of the Tangible Compass, which we later showcased at the Shenzhen Library. Our project was recognized as the best solution of the competition, earning first place and receiving high praise from industry professionals.
With the achievement described above, we do not stagnate here, but keep iterating our design for optimization. Our primary focus was on balancing compact portability with full kinetic functionality while keeping production costs low. And this is our redesigned prototype. It has several 3D pointed components like motor adapter, main panel, and force feedback sector. For electronical components, we use a 6-way micro DC motor and classical Wi-Fi module PCB development board. Such a setup is really replicable and low cost, making it ideal for prototyping and community deployments.
Tangible Compass introduces a 1 degree of freedom kinesthetic mechanism to deliver both directional and gradient force feedback. This allows users to perceive quantitative information through physical force cues rather than visual or auditory channels. Mechanically, the system uses a handle connected through a lever and capstan pulley setup, where force feedback is generated based on orientation deviation from a target angle. You can see from the force graph that the felt force increases proportionally with the orientation deviation. An important innovation here is the adjustable lever arm ratio between the handle and the sector. By tuning this ratio, we can amplify or attenuate the handle's resistance without increasing electrical power. This design makes the device extremely energy efficient and scalable, which is ideal for wearable or battery-operated applications where power consumption is critical.
Here's an additional demo on the orientation navigation setup, which is the primary function of the device as a compass that you can actually feel the force. We also tested the additional functions on the device. For example, the clearance detection. Here, the device helps the users to avoid nearby obstacles, and by detecting the distance of the obstacles ahead, it gives warnings through force feedback, allowing the users to adjust their path safely. The demo on the bottom right shows we use the smartphone depth sensors to measure the distance, and when an obstacle is closer, the user feels more frequent force signals, helping them steer clear of danger. These two applications demonstrate how the tangible compass can provide a more intuitive and safe navigation experience, especially for blind and low vision users. We also put a lot of effort into showing our results to the public. For this version of design, we submitted a technical research paper as the documentation of tangible compass to CHCHI 2024 and got accepted. Li Liuwen and Le Chengwang presented the Craft Square team and introduced the project to the broader HCI and accessibility research community. Additionally, Haha and Harry showcased this work at the STEM Expo held at the University of Washington, where we interacted with audience, explained how Tangible Compass works, and letting them experience the device firsthand. It was an amazing opportunity to engage with people, get feedback, and share our commitment to improve accessible navigation.
This is not the end of the story after all the journey above, and we're still on the track of making tangible complex impacts even further. As one aspect, we envisioned a more inclusive ecosystem where BLV users aren't just the recipients of the artifacts, but also the drivers of this development. By doing so, we built an ecosystem of tangible complex that grows and evolves continuously in a co-designed business model. After laying the foundation for this vision, we took our idea to the Diamond Challenge, a platform where we could show our concepts, and in there, we took things a step further, such as adding an AI-powered camera, but more importantly, we focused it on how we could rethink who gets involved in this process. Instead of just designing for a BLV user, we also started designing with them and inviting them to help promote the product themselves. Although it was just a simulation, it allowed us to test the idea of giving BLV user more ownership over the technology they use. This approach could eventually lead to greater empowerment and an inclusive ecosystem.
The technical design iteration is also not stagnated, where we want to bring the opportunity to more students to experience how fun STEM and research can be. So, we brought together a group of undergraduate engineering students joining the Craft Square team, and apply their knowledge and skills to make a difference. Their projects are fully led by themselves. They look up related works, learn new skills, run experiments, and build prototypes. Along the way, experienced members from Craft Square help and guide them. Right now, they're working on a really cool device for the BLV community. After selecting the destination on the phone, users won't need to hold the phone anymore. Instead, they can navigate smoothly and intuitively with the device they've developed, offering a truly screenless experience.
So throughout our research and development journey, the Craft Square team has put tremendous effort into this progress of the Tangible Compass project series so that we can present such an exciting result here to you. And we would like to give the highest appreciation to all the contributors from our team here. We have also received support from various fields and organizations, and we'd like to take this chance to acknowledge their help along the way. And also, as a student research oriented lab, Craft Square is dedicated to investigate and tackle realistic scenarios utilizing the resources that can be reached in our daily life and convert them into open source educational resources. And as a team, we chose this project based on the vision and to hope to share our insights that can help in other academic studies, while contributing a platform that could be utilized for a more comprehensive device that require further investigation. And If you enjoy it, and thank you all for your time.